As human civilization evolved, it gradually uncovered many mysteries of the universe. People began to ask themselves, what is matter, and what is matter made of? They became profoundly intrigued by matter, the things they could see and touch. More importantly, they wanted to know, what lies within these things, and what are they truly made of? These questions puzzled many great thinkers throughout history. But over time, some answers began to emerge. There have been many models of the structure of the atom, each widely accepted in its time. Around 400 BC, a pre-Socratic Greek philosopher named Leucippus proposed the idea that matter is composed of an indivisible particle called atomos. Later, his student Democritus further developed this idea and formulated one of the earliest concepts of atomic theory. According to this model, an atom could not be divided into smaller units of matter. There were also many types of atoms of different sizes and shapes, which could combine in various ways to form all objects and substances in the universe. The first model of the atom that was widely recognized was Dalton's atomic theory, which was proposed by John Dalton in 1803 AD. In this model, the atom is described as an indivisible solid particle that makes up all matter. According to this theory, atoms cannot be created nor destroyed, and atoms are rearranged during chemical reactions to form different compounds. However, this theory was disproven after the discovery of electrons inside the atom in 1897 AD. After the discovery of electrons by J. Thomson in 1897, he proposed his own model of atomic structure called the Plum pudding model. In this model, the atom consists of electrons and positively charged particles. However, he did not know the exact locations of the electrons or the positive charges within the atom, nor the nature of the positive charges themselves. This model was later disproven after the gold foil experiment. Between 1906 AD and 1913 AD, scientists Hans Geiger and Ernest Marston, under the supervision of physicist Ernest Rutherford, conducted the gold foil experiment. This experiment transformed our understanding of atomic structure and led to Rutherford's model. According to this model, the atom is mostly empty with the nucleus at the center, and the electrons revolve around it. Although this model was a great advancement, it was still incomplete as it did not incorporate the principles of quantum physics. Even though Rutherford's model was incomplete, Niels Bohr, inspired by Max Planck's work on quantum physics, further improved it by quantizing the electron's energy and proposed Bohr's atomic model. This solved many problems related to the orbit of electrons in Rutherford's model. Although Bohr's atomic model incorporated some quantum concepts, it was still far from complete. It was still inaccurate and conflicted with key principles of quantum physics, such as Heisenberg's uncertainty principle and the Pauli exclusion principle. But this model was a crucial step toward the most accurate model of the atom that we have today. Building on Bohr's model, scientists developed the current most accurate model of atomic structure, the quantum mechanical model. This model is based on all the principles of quantum physics discovered so far and provides an in-depth description of everything inside the atom. Currently, this model seems flawless because it addresses all known details and solves all problems of atomic behavior. But does that mean it is the final form? Well, for now, it is the final form. It is the most accurate model that we have, unless we suddenly stumble upon something about the atoms that cannot be described with quantum physics. These were the different models of the atom throughout history. The models evolved from a solid sphere to the quantum mechanical model, and each of them helped us understand the atom better. Thanks for watching.